Hi guys, thank you for coming to the Olewave weekly meetup session again. Today, we're going to be sharing from Whisper to your own in-house ASR service series. Today's topic would be how to handle the long audio and the streaming speech recognition. And over here, you can see this is our Olewave YouTube channel. Please don't forget to subscribe it. And also, this is our weekly or bi-weekly meetup. If you're interested, you can join us too. I think most of you have watched my part 1 overview and part 2 return on investment. They are all in my YouTube channel. Today, I think we're going to be check the part 3, how to handle the long audio and streaming. And there are some difference between the long audio and streaming. I will go over with the long audio first. What's the limitation of the Whisper? So I've been keeping a close eye on the Whisper version 1, 2, and 3 models. They are basically transformer models. They can only take in audio that's no longer than 30 seconds. So if you send an audio of 1 minute, 2 minutes into it, the model will give you an error. But the interesting thing is that Whisper, it can take a prompt as input like the large language models or ChatGPT, text plus audio case. I don't want to go over the reference documentation. You can check it on the Whisper examples. They have close, detailed examples there. I think lots of people have go over that. I don't want to do this. And they do have in their example scripts, they give I call it guidance on how to handle long audio ASR. So what they do is that they recommend you first to recognize the first 30 seconds of this audio and get the recognition results and use that results as a prompt, and together with the second or the next 30 seconds of audio, together they send it into the Whisper model, and you can recognize another 30 seconds of audio and get another prompt, and then you keep feeding the previous prompts or history of recognize the text into the Whisper model. Then you can always keep the audio input to be less than 30 seconds, but you can maintain sort of a recognition history. So the recognition is always contextualized. So what's the problem here? Let me point a very easy to find problem, even you're not speech recognition people. So suppose you segment on top of a word. For example, I say Costanza, but what if you segment on the sound after T, and you get first a second you got cost, and the second you got stanza. Then basically you're screwed, right? And more importantly, although I have not seen the training script of Whisper, I guess nobody outside OpenAI can. I think this way of recognizing the audio or inference audio should have a mismatch from its training stage. Because think about the training stage. Most of the time, they would be segmenting the audio into 30 seconds of segments, right? And they never segment in the middle of or for people who prepare the training data, nobody would think about prepare some text, they cut the text in the middle of the sentence and send it to the Whisper training, right? But if you are following the Whisper's guidance, then you are sending the incomplete recognition history or incomplete utterance as prompt to the Whisper inference. That's a problem, and we call the mismatch in the deep learning terminology. So I guess some of you might be familiar with the third-party solutions. There are tons of, there are many. I don't want to list them one by one today, but I would mainly categorize them into two categories. The first is they try to avoid segmenting on a word. For example, they use a voice activity detector, a VAD, which is to detect when people are speaking and when people are not. They're trying to segment on the silence or when people are not speaking. This is smart. I agree with them. But let me tell you, according to my knowledge, as far as I know, there's no 100% correct VAD. So segmentation errors definitely would propagate, or they're not recoverable. That's an issue. And it's not a recommended procedure in the speech recognition too. You don't want to do VAD first, then you do recognition. Because this is called cascaded system, VAD plus VAR, ASR. This cascaded system has been proved to be performing with less accuracy compared to a system that is more end-to-end. Make sense? The second way is that they use segment with overlap. In this way, they do not, how do you say that? They try to retain as much information as possible. So basically, they send the first 30 seconds of audio in, and then at the time stamp of 28 seconds, they start to recognize the next segment. So there's an overlap of 2 seconds. In this way, they avoid the segmentation problem, you can see. But there are new problems emerging. First, what if for the first segment, on the last 2 seconds, you recognize the words as A, B, and C, but for the second segment, on the first 2 seconds, your recognition results are X, Y, and Z. So A, B, C, and X, Y, Z there are disagreement. So how do you conciliate? What do you say that? How do you mitigate this disagreement? Then you have to train the model, right? Or you want to use human developed rules or some fuzzy rules. And also, in this way, there's no way for you to prevent yourself from segmenting the word on a word, but it's alleviated. So the segmentation errors are recoverable, but you definitely need more sophisticated post-processing to handle this case. But according to what I see on the GitHub repos, they don't have them. Okay. So, wait, you're working this domain for some time. Can you suggest any better solutions? Okay. The first thing I was thinking is you can definitely, we should explore more in the prompt engineering with Whisper. Think about for the large language models. Right now, if you're saying the large language model has some drawbacks or something, there's nothing you can do to it mostly, except prompt engineering. Try to use the proper prompt to stimulate the model to give you the correct result. But this way, I would say, I'm not completely objected this way because you never knows what prompt will give you the best result. Although all the current prompt engineering efforts seems to be not very effective, but you don't know when and who will get you a better prompt engineering procedure or protocol. Basically, this approach is ad hoc and unpredictable. I think you would all agree with me. The second approach, what I would recommend is you fine-tune the Whisper. Like I mentioned in the past 2 sessions, especially the second session, I mentioned the importance of the fine-tune Whisper. Interestingly, a fine-tune Whisper, you don't need lots of computing resources. All you need is data. And with this data, and especially design algorithm, you can teach the Whisper when to segment. Today's session is short. I don't have time to go over these paths. But if you're a prophet and you're interested in this approach, you can definitely contact me, okay? The second session is I will talk about streaming. Streaming is different than the long audio speech recognition. You can see long audio speech recognition, people usually mean it's done offline. You don't have to give me back the result back as I send it to you. But the streaming is, think about when you're using Alexa, right? Sometimes you can see that while you're keeping speaking, sometimes it would interrupt you, right? For example, you want to say, I want to play this music. And suppose you're keeping speaking, but they start to play music or give you some feedbacks, right? So this is streaming. And it's duplex. Just remember, the take-home word is duplex. It will taking the audio and send back the results at the same time. But what does the current Whisper model do? Even this is version 3 with ChatGPT. I show you an app interface people are using, right? Basically, it's first listening, then speak, right? When they're listening, they're not talking or they're not showing any text on the screen. That means they're calling their own internal Whisper API. I think their internal Whisper API might be better than the public Whisper API, or maybe it's the same thing. I don't know, but definitely their API is an offline ASR API, which cannot be working in a duplex mode, which means that it will first wait you to finish. Once it finishes, it will start recognition. So this is why you see the cloud, you see the animation of cloud while they're processing your speech. So some people may say, wait, you're not right. I know large language models or ChatGPT, it is an autoregressive method. It will pop out word by word, right? That's right. So this is why when you're using ChatGPT, when you finish typing your question, ChatGPT will start to pop the first word as soon as possible. Am I right? But I would definitely attribute the wait time to the speech recognition. Because suppose you have said 5 seconds of audio or even 10 seconds of audio, and it will start to use the Whisper encoder to encode all the speech into a sequence of embeddings. This procedure takes time. But I agree with you. For the next stage, they will use Whisper decoder to decode those the sequence of embeddings, okay? Then it will come out one word by another word. You don't have to wait. Talking about online speech recognition or streaming recognition, there are certain third-party solutions on the GitHub. Basically, what I've seen is that I highly do not recommend you to try any of their solutions, except that they show concrete word error numbers. I mean, benchmarks with the offline speech recognition results. Because theoretically speaking, I'm speaking to you as a speech researcher for many years. A streaming ASR theoretically has a lower WER than its offline counterparts. What I mean is that because for offline speech recognition, your context is the whole utterance or the whole recording, right? You have more information to decide what the current word was being spoken. But for the streaming ASR, you can only assess the history and the current information, but not the future. So what I meant is that suppose I say I'm gonna go to school tomorrow. I'm gonna see John. if you're trying to tell I'm going to where, but you cannot use the information of John. Suppose you know John is at school, you cannot use that information because for the streaming ASR, the only thing you know is I'm gonna go. That's the history. Okay, so I think if you ask a solution from me, I would say definitely if you want to go with a high ROI, high return on investment approach, I think transfer learning is the way to go. But this will be very, very complicated. Why? And let me tell you, in the near future, I wouldn't predict the OpenAI to launch a streaming or online Whisper AI API soon. The reason was that if you're talking about the model per se, it's not very difficult to train. But when I say it's not very difficult, it's for a speech R&D team. You have to build a dedicated speech R&D team. And which was results, I think, for people who watched my second part of audio video, you will know that once you have a dedicated speech R&D team, you would result in a low return on investment. And what is really prohibiting them from doing this, I think, is also the second option, a second reason. Serving a streaming-based ASR is more sophisticated than the current Whisper API. Because the current Whisper API, I think they're using the sessionless API. What I mean by sessionless is that look at the ChatGPT or Whisper. All you have to do is you prepare a chunk of information. You package the chunk, for example, audio, text, and video, and to the Whisper, right? And the Whisper API get back to a result. So you don't have, there's no duplex involved here, or bi-direction communication going on here. But you may argue, wait, ChatGPT use a dialogue style to communicate with you. You're right, but every time when every time you call the ChatGPT API, you're putting the history into the prompt section. Am I right? So this is, for them, this is still sessionless deployment. But for the streaming ASR, this is called session connection or something like this. You have to maintain a session. The session would be just dedicated to that user, and then when the person is keeping speaking, the session is occupied by that, and your session is supposed to be bi-directional operational, right? And this requires also a dedicated DevOps team. Even though you're deploying this on the cloud, I think people will definitely complain about lots of the issues which are not existing in the offline ASR. For instance, latency. And streaming ASR, you are expecting the ASR to be start to functioning or get you the first word right after you said the first word, right? So usually people are not expecting this delay to be longer than 0.5 or 0.1 seconds. Sorry, they're not expecting the delay to be longer than 1 second, because this is what people expect when they're having conversation with human being. They're not expecting you to starting to react after the person finished talking, right? When you say that, are you there? The person has to nod their head, right? Have the instant response. That's the point of streaming. All right, I'll be stop the sharing today. Just to let you know that we're a data vendor. We curate data sets, and we are better than the traditional vendors. I will stop the recording, and thanks for coming, and I will see you next time.